Okay, well, welcome back. We're here with BradEfron, our colleague here at Stanford. Um, Trevor and I were students here from 1980 to 1984, roughly, and Brad was our professor. He was actually my principal supervisor. And Brad's been here since when?
I started as a student in 1960.
1960, and then professor here since 68, is that right?
Well, I was assistant professor at 65 or 4, and then worked my way up the ladder to my present high position.
Now, in the course, we talked about the bootstrap, which is a very important method in statistics, and Brad invented the bootstrap about a year before we got here, right, in 1879. So you want to tell us a bit about how the idea came?
Right. Well, it's a story about having good colleagues. Rupert Miller, my advisor, was a leader in trying to understand the jackknife, which was Tukey's adaptation of Canuys' brilliant idea. And Rupert had written a paper called The Trustworthy Jackknife. They were trying to understand when the jackknife worked. And I went into David Cox's department for a year at the same time as Rupert, 1972-73. And Rupert gave another good talk on it. And afterwards, David Cox came up to me and said, in his inimitable way, that might be a good thing to work on. He didn't say it quite that way. He said it in a more elegant, English, restrained way, but it stuck in my mind. And at that point, I was working on curvature and stuff like that. And I got back, and I had written one line down on a piece of paper, which was, what is the jackknife an approximation to? And that got me going on it. And
how long did it take to write the paper? Remember, how long did it take to write the
Oh, a few months, and it didn't. And I must say, at the time, it did not seem like a especially special paper.
And what did the journal say? Were they...
Well, first of all, I gave it as the Reitz lecture. It was in Seattle, and I got some nice comments and also some criticisms. Wolfowitz was there, and he stood up and said, what theorems support this? And I said something wise like, well, I didn't want to ruin a perfect effort. But when the paper came back, Rupert was the editor of the Annals of Statistics, and the paper came back, it was sort of rejected, and the associate editor, who was, it turned out to be John Hartigan, sort of raised the same objections. Hartigan had work on half sampling, which is quite similar, and Tukey didn't like the bootstrap, and so there was some opposition. Tukey's objections were aesthetic. He thought that it was clumsy compared to the jackknife, which it is. It's a computer-based method, and it doesn't have to be computer-based in theory, but in fact, there's no way to do it except with the computer. I had to really work. I put a big, long appendix on the paper that then Rupert, grudgingly, I must say, accepted. And I'm sure if I didn't have him next door to me as my former advisor, I don't think I could have had it published. Which made me realize subsequently, and I've been editors of things, is that papers that arouse a lot of opposition should be looked at carefully by editors. Most of them are junk. That's the reason they get it. But some of them, the opposition is because there's actually a new idea.
And then, luckily for us, while we were graduate students, your little monograph came out, which was the jackknife, the bootstrap, and other resampling plans.
Yeah, you can see from the title that I was still thinking about the jackknife.
Yeah. I think the idea was really far ahead of its time. I remember as a graduate student, someone in physics asked you to give a talk on the bootstrap in physics. And you were busy, so you asked me to go to give a talk, right? So I gave just a general talk about the bootstrap. The physicists, this is about 1983 or something. And the physicists, they basically, they accepted it right away. Oh, yeah, of course, you're doing simulation, right? For them, the bootstrap was very natural. Whereas in our field, statistics, which really grew out of mathematics, it took a much longer time for the field to embrace the idea of using simulation to actually to make inferences. Where in fields that needed computation earlier, like physics,
Yeah.
it was a much more natural idea.
And I found that too. And then for the next several years, and you know this because you worked with me on this, we worked on trying to make the bootstrap work better than just be a plug-in first order method. And for me, this was very important because I wanted to show that it connected to statistical inference in a deeper way than just plus or minus something.
Was that the first name you thought of, the bootstrap? Were there other?
The end of the bootstrap paper has a joke on it, which shows that I wasn't taking it very seriously. I was kidding Tukey. Tukey had said about the jackknife that it was a rough and ready tool, good for any purpose. Yeah. And I said at the end that I thought of calling it the shotgun, which could blow the head off of any problem if you could stand the mess. And I don't think Tukey appreciated that either. Tukey asked me a couple times if we could write a paper together, and I vastly admired Tukey, and I would never write a paper with him. He's way too difficult.
Now, 30 years have passed, so I guess the field has changed. Is the bootstrap still important, and are there problems to solve in the bootstrap modern computation?
Good question. Or am I a has-been? Is that can I rephrase it that way? So I didn't work. I've worked about 10 years on the bootstrap and then quit because I didn't have any more ideas. And then in about 10 years ago, I started working on more empirical Bayes stuff, which goes back to my early 1960s work with Carl Morris. And at this time, it was in the context that you and I worked together on microarrays. And gradually, the bootstrap has reappeared in my work because it's a convenient way to do certain kinds of Bayesian calculations. And moreover, not just to do them, but to understand why Bayesian calculations are really more closely related to frequentist work than is obvious. Percy, it was just Dennis Lindley's 90th birthday, and various people, including myself, were asked to write little things about it. And Percy showed me what he wrote about how he took a lot of guff from the Bayesians for having helped me. We wrote together for Scientific American on the bootstrap, and they said, Lindley said that the bootstrap was just the most egregious of frequentist nonsense. And yet I think that it's quite closely related to Bayes theory. And as a matter of fact, I'm trying to write a book now, which has started out really wonderfully, called Computer Age Statistical Inference, available soon, and in which I will try and make the connections more between Bayesian and frequentist inference, and the bootstrap's an important part of that.
So you don't plan to retire soon? You don't plan to?
Plan is a strong word at age 75.
You must have seen big changes in data analysis over the years.
Yes, and I've seen over my career, which is mainly a lot of the applied work was at the medical school with you too, and you too, come to think of it, is the changes are phenomenal from looking at 1964, a data set that fit on one page that was pretty much solved using versions of the t-test was pretty much it. And then I could get Jerry Halpern to help me with the computer and do things, one batch at a time. And now, and I'm no great shakes at the computer, but I can go 100 times faster than I used to. And I can do the new tools that are available, like Cox proportional hazard, or generalized linear models, or GLMs, or whatever, which your book is really quite eloquent on, are just wonderful. Those are all in what I would call, most of that's in the pre-inference stage, in the algorithmic stage, and it's much harder, and the field has been much slower at doing the inference part of that, and saying how, for example, how well, is there a lower limit on how well you can predict? upper limit on how well you can predict. We don't have something like the Khmer Rouge lower bound.
By the way, Brad is a pretty big shake on the computer. He writes his own R code. He's got his own library of R functions. And whenever we work on a problem together, Brad always wants to program it up himself and see how it works. So he's a real hands-on person.
Well, I think it's also true that science has really changed our field. You told me at one point that in the past you used to sort of sit at your desk and try to think of things to work on. But then you started working in the medical school and doing more applied problems, and they actually, the problems that arose there, they informed you on what to work on, so that you couldn't believe in the past that you'd actually sit there and just sort of make up problems. Now most of your work, is that right, comes from...
I've gone a little bit back to the makeup problems, mainly because I haven't honestly kept up with the microbiology statistics work. It's just gotten too much for me. Yeah, I can do an R code and stuff like that with your help usually, and I can do this and that. But I'm not. I just so envy people who are real naturals at the computer, and naturals in the sense of being able to work flexibly with the theory and not get overwhelmed by the details, which are, to me, just overwhelming.
I taught Trevor most of his programming skills, so fortunately.
Yeah, Trevor is just remarkably good at that stuff.
Oh, thank you, Brad. We have some inside jokes here.
You wrote a large part of the software I use. Yeah. You didn't.
Well, Brad, it's been wonderful working with you. Yeah. The bootstrap is used everywhere in applied statistics. I think anybody who learns applied statistics ends up using the bootstrap one way or another. And so you've got a wonderful legacy. Yeah.
Legacy. Okay.
Thank you.
Sure. Thank you, guys.
Yeah.